So today we are going to be solving question 2050, and this question is in the hard category. It was asked at Google and Pinterest. The title is Parallel Courses 3, and what we are going to do is we're going to read the description and we are going to talk about how we can solve it on a high level. Then we are going to dive into the code. So the question states, you are given an integer n, which indicates that there are n courses labeled from 1 to n. You are also given a 2D integer array relations, where relations j denotes that there is a previous course j and there's a next course j, kind of like a link in between both of them. And essentially, it also tells us that the previous course has to be completed before the next course. And then we are also given a time array, and that time array holds how many months it takes to complete the ith course, or the course at index I plus 1. So we're given some rules, and we have to find the minimum number of months that is needed to complete all the courses, and we must follow these rules where we can start taking a course at any time, and any number of courses can be taken at the same time. So the goal is to return the number of months needed to complete all the courses, but the minimum. So looking at the examples that we have here, we can see that here the n is 3, and these are the relations, and this is the time that it takes to complete each course. So with the help of this graph, we can see that at the first course, it takes 3 months, while the second course takes 2 months, and then the third course takes 3 months. But yeah, we can spend 3 months taking both course 1 and course 2 because they overlap, and then we can spend 5 months taking the last course. So at the end of the day, we can have a minimum of 8 months to complete all the courses. And yeah, that works for the first example. So let's look at the second example. So yeah, we have our n to be 5, which means we have 5 courses. And using the graph, we can see that the first course takes 1 month, the second course takes 2 months, and the third course takes 3 months. And we can also see that other courses have a direct relationship to the last course, while the third course has a course that needs to be completed before we complete the last course. So at the end of the day, we can see that out of these 3 courses, we can use 3 months to cover these 3, and then an extra 4 months, and then 5 months for the last course. So that gives us a total of 12 months. So using these 2 examples, we can thereby talk about how we can solve or approach this question on a high level. So we are going to be using a technique known as DFS, and it stands for depth first search. And we're going to use that plus memorization to solve this question. So let's imagine that we have this example graph that I have on the screen right now. And let's also assume that all the numbers in the nodes stand for the time it takes to complete each of those courses. So the idea here is we are going to find the part that has the longest time, so that is going to accommodate the time it takes to complete all the courses. So as we can see here, from this node, it will take us 17 months to complete this course. And when we add that to the last node, that's 19. And for all these other nodes, it will take us 9 plus 5, which is 14. And we can see that out of these 3 nodes that are currently the dependency for this other course, or the requirements before we can take this other course that has the time of 5 to complete, we can see that 9 is the largest. So essentially, we are going to be taking the longest, the part that has the largest time to complete, and we are going to return that as our answer. So in this case, our answer is going to be 19. So let's define a function DFS that takes in an argument node which represents the course, and this function is going to recursively call itself to find all the total time it takes to complete all the courses along that part. So for example, when we pass in this first node here, this one at the top that takes 9 months to complete, it's going to calculate all the courses along that path with the last course. And that's going to give us a total of 9 plus 5 plus 2, which is going to be 16. And then we are going to do the same thing. We are going to pass in the next node. And that's going to give us 7 plus 5 plus 2, which is going to be, I think, 14. But that's not going to, we're also going to do the same thing. We're going to pass in 8 plus 5 plus 2, which is going to give us 15. And we're going to pass in this node, which is going to give us 17 plus 2, which is 19. So just like we explained before, we are going to take the maximum out of all those parts, and that will be our answer. But looking at this graph, we can also see that these 3 nodes or these 3 courses point to this other course, which means by the time we have calculated this first node here, or this first course, we would have ultimately found the time it takes to complete this course till the end. So this is a very simple example, but imagine in a more complex graph where we have so many dependencies. This will help us eliminate redundant calls. So when working or trying to calculate the costs or the time it takes to study this particular course, that's 7, once we get here, we can just ultimately return the answer from this down here. And then we can keep going on and do the same thing. So that way it helps us to optimize our code. So we are back now in the IDE, LeetCode IDE. So let's write the code and let's see how that looks like, what it looks like in code. So the first thing we're going to do is we're going to build an adjacent list. And essentially we are creating an array, and we are going to use the length of the number of courses we have plus 1. And the reason why we're using plus 1 is because we were told that it is labeled 1 to n, but what we want to do is we want to be able to access the adjacent nodes using the actual number. So we are not, even though it should be 0 index, but we want to access it using the number directly. So if that's not clear, you'll see what we mean as we move further. So yeah, we are now going to loop. We're now going to loop through the relations, and then we are going to have the prev course and the next course of the relation. And then we are going to say we're going to populate the prev course at j. We're going to push in the next course. So essentially what we are doing here is we are saying we are looping through these relations here, and we are saying at the index 1. So this is what I meant by we're doing n plus 1 instead of using n. So we are skipping the whole first index, and we're starting from 1. So at the index of 1, we are going to push in 3. At the index of 2, we are going to push in 3. Essentially, we are saying that these 2 nodes have an adjacent node, which is 3. So after doing that, the next thing we are going to do now is we're going to define our function DFS that takes in the node. And what we are going to do here essentially is we are going to say for each of the children of that node. So we are going to say adjacent node. So this adjacent node gives us access to all the neighbors, or all the nodes that are going to be completed next after this node, or the other nodes in the path. So we're going to do a for each. And we are going to say for each of them, we are going to calculate the DFS for that node. So essentially, we are going to call this function again. So we are going to also, let's define a variable max. We are going to say, yeah, for every of the nodes, we are going to calculate the maximum. So it's going to be max is equal to math.max, and then the DFS of that node. So so looking at this graph, just like if we're talking about the node or the cost 3, it's going to have two courses that can be taken next, which is 5 and 4. But when we calculate both of them, the maximum here is going to be this part. This part has more courses along it than this one. So essentially, that's what we are doing here. So when we get that maximum, we are going to add it. We're going to say let total be the time. So we also told that the time is 0 days, so which means we're going to say node -1, and then we're going to add our max to it, and then we can return that total. But before we leave here, let's also remember that we talked about caching and that so we can optimize our code. So let's quickly add that. And the reason why we are doing that is, for example, if we have other nodes that we're pointing to 4, once we have found the time it takes to get from 4 to 5, we don't need to keep on doing that, and it just helps to speed up our code. So after finding the total, we are just going to cache the result and say that node, this is the total time it takes. So after doing that, now we are going to loop through all the courses, and we are now going to say the one that has the maximum parts. So we are going to loop through all these courses, and we are going to say the one that has the maximum parts is our answer. So essentially, we are looping from I equal to 0, I less than n, less than or equal to n, plus I, and then we are going to calculate it. So after that, we can return our max. If all went well, that should work. Okay, so we have an error somewhere. Oh yeah, first thing, if we have node in the cache, so to use our cache, if we have node in the cache, we are going to return the results from there. So that's the first thing. Oh yeah, we have an error here. This shouldn't be node, this should be n. And yeah, one more other thing to fix. This shouldn't be 0, this should be 1, because we were told in the question that we start from 1 to n. Yeah, so let's run our code finally. And yeah, so that's the answer. So yeah, if you have any question, hit me in the comment section and I'll be happy to help.